in last class. Okay, so we discuss about RIP routing protocol, routing information protocol, and RIP has two versions. It is a type of dynamic protocol, right? And in the dynamic routing protocol, so okay. Okay. So in routing protocol, we have static. We have three types: static, dynamic. Sorry, static, default, and dynamic. So static we have seen, default we use for the internet, and in dynamic we need to see three protocols. Um, First is the advanced distance vector protocol. Okay, we discuss about the RIP. So in RIP, the distance, the timers, right? So 30 second, 180 second, 240 second. So it maintain the hop counts. Okay, so and we have seen the lab also. So we created three networks: India, USA, and UK, and we shut down like India LAN, and we check in the UK LAN that after 240 seconds we are coming to know that the network is down. So this protocol was a legacy protocol. Okay, so it has the slowness and all. So RIP 1 is dead and RIP 2 is still there. So RIP has the two versions, version 1 and version 2. So version 2, we know that it used the VLSM, and it can have it do summary routes and support authentication, trigger update, and it used the multicasting. But RIP version 1, it was using the broadcasting. Okay, so it was the RIP, and the configuration was very simple. Just need to go config terminal, and you need to advertise your directly connected network. That's it. In static route we use whatever the non-directly connected network, but here directly connected network, right? So do you Umar, have you done the practice for the RIP? Hello? Okay, problem. Okay, no problem. So let me start the packet tracer, so we will see that our diagram. So in packet tracer, if you remember, you can make a base topology, okay, and use that topology multiple times. Okay, so still opening. Okay. So oh, here we go. So if you see here recent files, so you can see it. Base I save or base topology something like that. So let me open that. So you can use that multiple times. Desktop, I think. Base. It was there. Let me check. One second. Give me 1 minute. I'm just I don't know where I lost that file. Static routing. Oh yeah, it is here. I found it. Okay, sharing back. Okay, can you please confirm you're seeing my screen?
Yes, I see your screen.
Okay, fine, perfect. So RIP. So see, if you do RIP, if you do OSPF, if you do EIGRP, all are like the configurations are very simple. Only the concepts are different. Okay, so RIP, like okay, so you remember this is our base diagram. So we have India, USA, and UK. Three networks. Okay, so this is our India LAN, this is our USA LAN, this is our UK LAN, and this is our WAN. So we know that there are five networks. So our agenda is if you want communication from the overall communication, like everyone can ping to each other, then every router need all five routes, all five networks. Then only the communication will happen, right? So if we go to India router and check, so IP route. Can you see the currently it is showing only the directly connected networks. Directly connected networks. Similarly, if you go to USA router, show IP route, you can see three directly connected networks. C means directly connected. So it's a by default. So directly connected three networks means one, two, and this three. Three networks are directly connected. And to UK router, let's see here. So IP route here two networks, one and two. Okay, so we have two networks. So in RIP, what we did RIP, how we configured. So what is again for you? I'm showing again. So um, you just need to configure your direct advertise your directly connected networks. So in India, okay, in India, okay. So how many directly connected networks? Two only, one and two. That's it. You just need to advertise that only. How to advertise? Config terminal router RIP, okay, network. What is LAN? 192.168.10.0. And what is our WAN? 1.0. That's it. Finish. Configuration done. Similarly, go to US router. How many directly connected networks? 192.168.1.0, 192.168.2.0, 192.168.20.0. Just advertise them into three. Config terminal router RIP network 192.168.20.0, 192.168.1.0, 192.168.2.0. Done. USA router done. Now just go to UK router terminal. Okay. Router with RIP 192.168.30.0 and 2.0. It's banned. That's it. What we did, we just advertise our own networks. So can I go here where I'm here. So what is who I am? Which machine it is? It is 192.168.10.10. So can this machine ping to UK LAN ping 192.168.30.10? If our routing is good, then it should ping. Can you see? It's pinging. And how it is pinging? Just do the trace set. 168.30.10. See, first it's going to the gateway, then the WAN 1, then WAN 2, then it's going to the UK LAN. So this is perfect. It means all the routers have the know each other. So let's verify that. India router. Okay, see, previously we had only the CC, means directly connected network. But now after configuring repo, what happened here? Show IP route. Can you see? The R means not. These are the route came via repo, and you can see the timers also. This is also timers. This is also timers. R means the three route which was missing. The RIP helped India router to uh, get it listed. So how it happened? So in dynamic routing, both router, RIP, both router, they change their full routing table. They exchange the routing table. India router exchange this one, and UK router extend to US router. So and US router it will extend to India, and it will extend to UP. UK router. So like this, the all network, all routers should get so IP router. Can you see? They all got the same. And finally this one also. So IP route, right? R. So all three routers came. So what was the problem in RIP? RIP was the problem was the timer. It was very slow protocol. It takes 240 seconds to understand. If any network down, it will take 240 seconds to understand, to learn the route or flush the route. So it was not a good one. So what happened? They started with a new routing protocol. So what is that routing protocol? The another one is OSPF. Okay, Open Shortest Path First protocol. This is the second dynamic routing protocol which we are seeing. So what is the focus here? Link state routing protocol. So the RIP was RIP was what is called distance vector protocol. OSPF is a link state protocol. Okay, so advantage, much faster to converge, no routing loops, forces you to design your network correctly. See, OSPF is much faster routing. Okay, and there are some disadvantages. What is that? Demand on router resources, because it will continuously involve routers to um, send the packets, and also router resources will be utilized. Required a solid network design and technical complexity. It is used for some technical stuff only. Like if you have some larger organization, so you should use it, and it required some uh, good technical design. So it is not like today you decided, okay, let's go for the OSPF. No, it has to be very planned and very in discuss, and then only it can do. So OSPF, open standard, open standard for OSPF stand for open shortest path first. Okay, it is a standard protocol. Okay, standard protocol means what? It can support Juniper, it can support Palo Alto, it can support Checkpoint. Every vendor support OSPF. This is one of the most famous protocol, OSPF. Okay, uh, standard protocol. It is a link state protocol. Okay, link state protocol. It uses shortest path first algorithm or Dijkstra algorithm. See, RIP was using another protocol algorithm, but this is using a digital algorithm. Okay, And can you see here OSPF unlimited hop count? RIP was having limitation of 16 hop count only, 15. So 16 router, but here unlimited in number of thousands of hop count you can use. So here it use a metric. Metric is nothing but the cost. What is the cost? It is like it is nothing but the 10 is to 8 by bandwidth. So this is a metric cost. So what is the metric cost? We'll see that. Then administrative distance is 110. It is a classless routing protocol. See, the classful routing protocol means it does not support subnetting. Classless routing protocol, it supports subnetting. Okay, so it support VLSM and SDR, CIDR. It support only equal cost load balancing. Introduce the new concept of area to ease management and control traffic. So OSPF it started a new concept called area. Okay, so what is the area? Area means, see, this is one of the diagram of the OSPF. So what happened is it uh, came with the idea called area. Area means nothing but the boundaries. Okay, so boundaries. So let's say these two routers, they are in the backbone. They are in the area zero. So area zero will be the origin of your network. So the other area should be connected to should have connectivity to the backbone. So can you see here this area 1, area 2, area 3? They all are like they are just having like CD, BD, EV. So they are connected with the origin or backbone network. And A and B, they are the solid area 0 network, area 0 in the OSPF. So this is called actually the autonomous system. So let's not go much complication for the first class. Who left here? Okay, no problem. So this is the first class. Let's not go much complication. So just remember this point. OSPF use the area. Okay, here we use the area, area zero, and area zero should be the connected into the um, area zero. You need to configure first, then we will configure multiple areas. So it has some more details that we will discuss in the next lecture. So just in today's class, I just wanted to show you something here. So in these routers, we just configured the RIP, right? So RIP was very slow protocol. Okay, so you can see here routes are here. So what happens? So if suppose this guy down, so it take much time. Okay, let me show you here. Show IP interface with terminal interface first 0.0. Sorry, giga ethernet. So see, just now what happened? We shut down the India LAN. Okay, so see, this is a technology, right? So if it is shut down, then um, we should get the update, right? Can you see 192.168.10.0? It is still not down. It is still showing in the routing table. So what will happen? So this route will take. Yesterday, Friday also we have seen it take around what is called 240 seconds, like around 4 minutes to remove it from the routing table. Till that time, what will happen? Till that time, it will start. It will think that this LAN is still in unit. Okay, so this was the problem in the RIP. So let me remove the RIP configuration. How to remove that? Just say config terminal no router RIP. Finish. The routing table one. Similarly, I will go here and I will say config terminal no RIP. Finish. See your routing protocol done. Finish. And here I will go router RIP. Now see what we did. We just removed the RIP configuration. So do you still able to ping? No, because your you see destination host unreachable. So it means that this router don't have a route for this. Okay, so you can say how it is possible. Like I had the route right just now. Show IP route. Yes, route was there because RIP was there. Now RIP gone, so it take the route also. So now nothing is I have. So let's configure the OSPF. The detail of OSPF we will see tomorrow also. Okay. Router. See question mark. Can you see here? RIP we just configure. So now we need to use the OSPF. OSPF. See if you put enter, what it is saying? Incomplete command. So here there is one more thing we need to put, that is called process ID. Process ID, it is used for used in the OSPF. So let's say I'm using process ID 1. Okay, it is a number. Then okay, then network. You need to advertise the network. 192.168.20. Sorry, 10.0. Okay. If you put this one, see in RIP we use just network and put enter. But can you see in OSPF it is not taking. So here we need to provide few more things. That is called the first thing subnet mask. So instead of subnet mask, we need to provide the reverse. That is called the wildcard mask. So like this is a class 24, right? So wildcard mask will be something like this. Okay. So let's say um, for class C 255.255.255.0. This is your subnet mask, right? So it should be the 255.255.255.255 minus your the broadcast minus subnet mask is equal to wildcard mask. So it will be, if you do the minus, what will happen? 0.0.0.0.25. Can you see this 255 is gone, this gone, 0.0.0 dot this one. So for the class C, for this network 192.168.10.0, what will be the wildcard mask? The wildcard mask will be 0.0.0.255. So all 255s will become 0, 0 will become 255. Simple. Next, now see area. We need to define the area. So how many areas we can create? Can you see this many areas we can create? So I will say area 0. For now, we are creating area 0. Network is area 0. Next, what is my another directly connected network? This is my network 1.0 and area 0 and wildcard mask and the area 0. Done. So the first thing is done. So what I did to do show history. See, I just configure these two commands. For the OSPF. Okay. So if I go there, okay, this is my Hyderabad router. This is done. India router. So now if I go and go for US router. Okay. First see show IP route. How many routes you have? So you have these three routes. See, you can see C means you this slash 24 slash 24 slash 24. So you just need to configure OSPF. So we are configuring area 0 network. So a router OSPF process ID will be same 1. Now network. What is the network? 192.168.20.0 wildcard mask 0.0.0.255 and area should be 0. Then what else I have? Okay, instead of this, what I can use? I can use the up arrow. See, the another A is 2.0. Okay. Now just see here. When I Now I'm adding 1.0. Now just you see here, within few seconds you will see some message here. Can you see here? See, adjacency, OSPF adjacency, process 1, neighbor 192.168.10.1 on this one, from loading to full, loading done. It means that OSPF means both routers, India and USA router, become neighbors. Congratulations. So they become neighbors. If you want to see that, you can say show OSPF, show IP, OSPF neighbor. Can you see? Like CDP neighbor, right? Now similarly, this is a protocol neighbor. So it is showing it become a neighbor. Okay. So what command I use here? I just show history. If I see show history, so can you see only three commands? See, configuration is very simple for routing, dynamic routing, but concept is important. So I use this one, and now let me configure the OSPF here also on the UK router. Config terminal, router, OSPF 1, network 192.168.30.0, 0.0.0.0, sorry, 255, area, this is done. Now, what is the another WAN 2.0? Can you see just can you see within a second in few seconds you got this neighbor sheet. So what does it mean? Show IP OSPF neighbor. Can you see it become a neighbor? And if I see the routing table, show IP route. Can you see? O, R means R, it was RIP. Now this is O. O means OSPF. See the what is called distance administrative distance 110, right? And you got the route. So if I go here, see, ultimate goal was by using dynamic routing protocol 30.0. See, both are ping. Are you following me? What is
Yes, yes, I follow.
okay? Fine. So anyway, this class I have to repeat again tomorrow because Muhammad and Umar, they both are not available.
Yes, yes, yes.
Okay. So 192.168. So ultimate goal was happening. So now our OSPF is working. So we got these guys are pinging. So how they are pinging? It happened because of OSPF. So can we go some detail on the OSPF? No, like this. Show IP. First one, show IP OSPF neighbor. With this you can see 20.0. Can you see 20.0 means neighbor ID? 20.0, who is the 20.0? Our US router, right? So if you go here and check in US router, so IP OSPF neighbor. Can you see? It's showing I have a two neighbor. One is a 10.1, one is a 30.1. So left side is the India, left right side is the UK, right? So it is having something like DR and BDR. We will see that tomorrow. DR, BDR, and so first command neighbor. It formed the neighbor. Then show IP route. If you see, so you can see the O. O means the if the route came via OSPF. O. One more there. Show IP OSPF database. It maintains the database actually of all the route, advertise route. These are the routes. So now, can you see the difference now? So now we are in UK. Okay, we are in UK. Show IP route. So here you can see all the routes. Here you can see all the routes. Or If you see here like this, via OSPF, how many route came to UK? Three. WAN 1, India LAN, and this one. So now what I'm going to do, I'm going to shut down this port of India router. Let's see how fast it will inform to everyone. Interface Giga Ethernet 0 by 0. Shutdown. See, I just did a shutdown. So I'm just going back to UK router. See, just now we were saying this three route. Can you see? It removed that. So what you understand with this? So OSPF is much quicker than the RIP. It has the link update. So if anything down, it will quickly send update that okay, this network is down, right? Now let this network come back. So what I will do, I will just take him back. No shutdown. So now let me go back to UK router. Okay, it was not there. Can you see now? Okay, okay. Can you see? It take some seconds, but now see 10 came back. So this is called a dynamic update. If anything down, up, something happens. Okay, see right now you are having this network, this thing. So what I'm going to do in India network, I'm going to add one virtual network. How can I do that? Interface loopback 0. Loopback is something IP. Uh, it is a virtual network I'm adding. IP address 1.1.1.1.255.0.0.0. Okay, I created one loopback. So I need to advertise that loopback into OSPF. How to advertise? Router OSPF 1. Under that OSPF, I'm just saying that network 1.0.0.0 0.255.255.25 area 0. Done. I just advertised some one network here. So can you see here? Is that network came here? I'm just saying done. Can you see? The new network came here, arrived here in OSPF, and where I am, I'm in the UK router. So see how quickly, dynamically they are updating to each other. That this network came up, this network went down. So this is a dynamic routing protocol, OSPF. Okay, and OSPF has three base commands. What are those commands? Show the first command, show IP OSPF neighbor. Who is your neighbor? Second command, show IP OSPF database. It will tell you what is your database. And finally, your routing table. Show IP OSPF. Show IP route. If you want to filter, just say show IP route OSPF. So you will filter. Okay, these are the route came to me. Okay. So what I'm going to do, I'm just going saying this network I don't want. No network. See, I just said no network here. So it removed from OSPF configuration. Can you see now? Boom, it gone. See, one network, it was there, now it gone. So so what we understand, OSPF is much faster than RIP. Do you agree with me?
Yes, yes.
Yes.
The
So
time taken to 4 minutes to 40 seconds.
exactly. So this is the difference you need to understand. So tomorrow we will continue this again. So we'll see some more detail of the OSPF. So, but for today, you just do this lab, RIP lab, and if you get time, OSPF also. Just configure. It is nothing, not much commands. Just you need to put four commands, and you already have in that your notepad, that routing notepad commands. So we'll discuss this again tomorrow. So we'll stop here because two guys are absent. So we'll see the OSPF continue tomorrow again. Okay.
Okay, okay, inshallah, I try to.
Okay, fine. So we'll see that.